All right, welcome back to another video. So I'm hoping to do a long one today. Once I get to that hour mark, what I've done in the past that has worked is I take like a 5 to 15 minute break, and then I come back and I can do 3 hours pretty easily if I do that. So I'm gonna try to do that. I have about 3 hours before another event. So let me see if I can get in at least 2 hours. But if I can only do an hour, then that might be have to be good enough. But what I'm gonna do is keep working on this agents course. I'm a little bit behind. Um, so the next yeah I'm going to start unit 2, so I'm not necessarily behind. If we go to this when are the next steps published and take a look, uh, so unit 2.2 is going to be out on Monday, so I'm not necessarily that far behind. All right, but this is Unit 2 and Unit 2 dot 1. So Unit 2 is Introduction to Agentic Frameworks. So we're gonna learn about three different frameworks: small agents, Llama Index, and LangGraph. So we're gonna start with small agents, LangGraph, and then Llama Index. Welcome to this unit, where we'll explore different agentic frameworks that can be used to build powerful agentic applications. We will study in Unit 2.1 small agents. There we go. And then Unit 2.2 will be released Monday. It's not available yet. That will be on Llama Index. And then Unit 2.3 will be on LangGraph. So let's dive in. Before we do that, let's take a look at these links, because I think this might be a link to the documentation. So if you want to work ahead and before that next unit is released, learn about Llama Index and LangGraph. Yeah, so here's the documentation. So you should be able to go to you should be able to go to like get started. I think you have to log in. Okay, and now you're in this kind of work panel. So you can see on the left there's documentation listed there. So if you want to get an early start, um, you can go to you can likely go to this documentation. Yeah, so the onboarding documentation, getting started, is probably the place to go. But it looks like there's really nothing to see here. It's just overview on how to use the UI, how to get an API key. Spoiler alert: you probably have to pay for it. Um, we probably don't have to pay for the key, but for usage, yeah. So down here we see the pricing. So it only charges for file parsing and is otherwise free to use. Okay, so that's a good deal. Yeah, so it looks like Llama this Llama Cloud is pretty solid, because uh, it only charges for file parsing. All right, so then here's LangGraph. This is something else. Let's take a brief look at that. Let's head over to careers very briefly and take a look at what they got. Uh, let's do full-time work uh, in let's do all departments, and let's just start with New York. So they've got so these are all on-site roles. You have to relocate to New York. So this might be a good one to check out by the end of Unit 2.3 to apply for this LangGraph Platform Infrastructure Engineer. Um, so they want 5 years of professional experience, strong proficiency in Kubernetes. So this is always gets tough because I don't know what they mean by that. If they want, you know, some or all of your 5 years of experience to match what they're looking for, yeah, and Terraform as well. So this is one of those posts where they're kind of looking for a unicorn. They want Terraform specifically for IAC. So, so the way to do that is if there's some sort of pretty easy certification or like Coursera course or something like that, that would probably be the way to go. Or even just to complete a tutorial. Um, yeah, hands-on experience of participating on call. So it looks like it's a lot of on call. It looks like you have to relocate to one of the highest cost of living areas in the country, either New York or California. Both are probably some of the highest in the country. It looks like you need at least 5 years of professional experience in infrastructure engineering or a related role. So that's kind of vague what that could mean. And you need strong proficiency in a lot of very specific things. Basic understanding of full stack development. So I don't know. It's so so uh, so yeah. That's I think it's important. The one thing I will say too to anyone watching this channel, even if you're not looking for a job, take a look at their job postings um, because the thing is like you're gonna be able to like reverse engineer your experience, right? Like if the jobs you want are all calling for this specific thing, you can try to do some freelancing in that specific thing. You can try to get a cert in that specific thing. Or you can even just like create a series of videos online based on the documentation of that certain thing. So like always like take a look at the job postings because even if you're not looking for a job, they can help. It can help to know what's out there. All right, so I don't see any postings there. So let's yeah. So these are the. It looks like all of them are on site. Here's a remote. So it looks like some of the London ones might be remote. There's a remote. Um, yeah, but location Europe, so I don't know what that means. Yeah, it doesn't say anything about because a lot of times what's a lot of times when job applications say that they're remote, that's a mistake in the application, and it doesn't mean that you're working in a home office online on like a VPN connection. Uh, it means either fully on site or some level of hybrid. All right. Well, anyway, moving on. So let's dive in. When to use an agentic framework. An agentic framework is not always needed when building an application around LLMs. They provide flexibility in the workflow to efficiently solve a specific task, but they're not always necessary. Sometimes predefined workflows are sufficient to fulfill user requests, and there is no need for an agentic framework. If the approach to build an agent is simple, like a chain of prompts, using plain code may be enough. The advantage is that the developer will have full control and understanding of their system without abstractions. Okay, so if you want to use a framework, um, then you'll get a lot of flexibility. But if your workflow is like really simple, um, an agentic framework may not be necessary. There might be a pre-existing, predefined workflow that you can just use wholesale rather than using a framework to build an agent. And also, if your agent itself is simple enough, you might not need a framework either. However, when the workflow becomes more complex, such as letting an LLM call functions or using multiple agents, these abstractions start to become helpful. Considering these ideas, we can already identify the need for some features. An LLM engine that powers the system, a list of tools the agent can access, a parser for extracting tool calls from the LLM output, a system prompt synced with the parser, a memory system, error logging and retry mechanisms to control LLM mistakes. We'll explore how these topics are resolved in various frameworks, including small agents, Llama Index, and LangGraph. All right, so we're going to go through this in various units. We're going to start with the small agents unit. So these are agents developed by Hugging Face. Of course, that's the one that's going forward. So unit author, let's make sure that we're following the unit author on LinkedIn. It's really important to curate a useful LinkedIn rather than just taking whatever is pushed to you by default. So, all right, looks good. On to the next, and I need a break. I'll be so now this is understanding introduction to small agents. Yeah, so unit 2.1. So I'll be right back. All right, welcome back. So let's keep going on this. So welcome to small agents. So this is unit 2.1, the small agents framework. Um, welcome to this module where you'll learn how to build effective agents using the small agents library, which involves a lightweight framework for creating capable AI agents. Small agents is a Hugging Face library. Therefore, we would appreciate your support by starring the small agents repository. I can do that. Oh, I already have it starred. Module overview. This module provides a comprehensive review of key concepts and practical strategies for building intelligent agents using small agents. With so many open source frameworks available, it's essential to understand the components and capabilities that make small agents a useful option or to determine when another solution might be a better fit. We'll explore critical agent types, including code agents designed for software development tasks, tool calling agents for creating modular function-driven workflows, and retrieval agents that access and synthesize information. Additionally, we'll cover the orchestration of multiple agents, as well as the integration of vision capabilities and web browsing, which unlock new possibilities for dynamic and context-aware applications. In this unit, Alfred, the agent from Unit 1, makes his return. This time he's using the small agents framework for his internal workings. Together we'll explore the key concepts behind this framework as Alfred tackles various tasks. Alfred is organizing a party at the Wayne Manor while the Wayne family is away and he has plenty to do. Join us as we showcase his journey and how he handles these tasks with small agents. In this unit, you will learn to build AI agents with the small agents library. Your agents will be able to search for data, execute code, and interact with web pages. You will also learn how to combine multiple agents to create more powerful systems. All right, so here's our agent, Alfred. Contents. During this unit on small agents, we cover one, why use small agents? Small agents is one of the many open source agent frameworks available for application development. Alternative options include Llama Index and LangGraph, which are also covered in other modules in this course. Small agents offers several key features that might make it a great fit for specific use cases, but we should always consider all options when selecting a framework. We'll explore the advantages and drawbacks of using small agents, helping you make an informed decision based on your project's requirements. Number two, code agents. Code agents are the primary type of agent in small agents. Instead of generating JSON or text, these agents produce Python code to perform actions. This module explores their purpose, functionality, and how they work, along with hands-on examples to showcase their capabilities. Number three, tool calling agents. Tool calling agents are the second type of agent supported by small agents. Unlike code agents, which generate Python code, these agents rely on JSON/text blobs that the system must parse and interpret to execute actions. This module covers their functionality, their key differences from code agents, and it provides an example to illustrate their usage. Number four, tools. As we saw in Unit 1, tools are functions that an LLM can use within an agentic system. They act as the essential building blocks for agent behavior. This module covers how to create tools, their structure, and different implementation methods using the tool class or the @tool decorator. You'll also learn about the default toolbox, how to share tools with the community, and how to load community contributed tools for use in your agents. Number three, retrieval agents. Retrieval agents allow models access to knowledge bases, making it possible to search, synthesize, and retrieve information from multiple sources. They leverage vector stores for efficient retrieval and implement retrieval augmented generation, also known as RAG, patterns. These agents are particularly useful for integrating web search with custom knowledge bases while maintaining conversation text through memory systems. This module explores implementation strategies, including fallback mechanisms for robust information retrieval. Number six, multi-agent systems. Orchestrating multiple agents effectively is crucial for building powerful multi-agent systems. By combining agents with different capabilities, such as a web search agent with a code execution agent, you can create more sophisticated solutions. This module focuses on designing, implementing, and managing multi-agent systems to maximize efficiency and reliability. Number seven, vision and browser agents. That would be really cool. Vision agents extend traditional agent capabilities by incorporating vision large language models, VLMs, enabling them to process and interpret visual information. This module explores how to design and integrate VLM-powered agents, unlocking advanced functionalities like image-based reasoning, visual data analysis, and multimodal interactions. We will also use vision agents to build a browser agent that can browse the web and extract information from it. So imagine like a you can make your own personal trainer, because if you set up a few cameras around the house, um, like one in the kitchen, one in like your workspace, and one in like an exercise place. Um, what you can do is like if you're going into the kitchen, your personal trainer agent can be like, hey, you've been in the kitchen quite a lot today, but you haven't been in your exercise space yet. Here's a workout. Like I know you said that you were tired from your workout yesterday, so here's a recovery workout where you can stretch and get blood flow to the areas that are sore and basically do like physical therapy. Or you haven't done any activity in the last week. Drop and give me 20 full good form push-ups, so lots and lots of potential with this. That's been something I've been wanting to build for myself for a long time. All right, so here's the resources. We're gonna use the small agents documentation, official docs for the small agents library. So this is the thing I always say to people watching my channel. This is where you go. You go to the docs and read the docs. RTFM can be a little bit like sometimes the docs aren't written well, but you can complain about the docs, but you can only complain about the docs after you've looked them over. But yeah, it's a lot of the times documentation is written pretty poor. It's confusing. It doesn't answer your question, or it requires way too much information, or it's off topic, or um, you know. But it's definitely the place to start. All right, so then we've got a research paper here, probably from from Anthropic. Okay, that's a surprise. Okay. Then we've got agent guidelines, best practices for building reliable agents. So this is part of the small agents documentation, not part of a course. Okay. Then we've got LangGraph agents. So additional examples of agent implementations using the LangGraph framework. Then we've got function code calling, understanding function calling in LLMs, and we've got RAG best practices, guide to implementing effective RAID. So there you have it. This course is nice, but um, if you're going to be a professional, you might not always have a nice curated course like this. So you're going to have to look at the official docs. You're going to have to look at research papers. You're going to have to look for any published guidelines out there, and look at examples and guides and best practices. But lucky for this, we do have this course. So let's continue. So license to call. Why use small agents? In this module, we'll explore the pros and cons of using small agents, helping you make an informed decision about whether it's the right framework for your needs. What is small agents? Small agents is a simple yet powerful framework for building AI agents. It provides LLMs with the agency to interact with the real world, such as searching or generating images. As we learned in Unit 1, AI agents are programs that use LLMs to generate thoughts based on observations to perform actions. Let's explore how this is implemented in small agents. Key advantages of small agents: simplicity, minimal code complexity and abstractions to make the framework easy to understand, adopt, and extend. Flexible LLM support works with any LLM through integration with Hugging Face tools and external APIs. Code first approach, first class support for code agents that write their actions directly in code, removing the need for parsing and simplifying tool calling. HF Hub integration, seamless integration with the Hugging Face Hub, allowing the use of Grado spaces as tools. When to use small agents. With these advantages in mind, When should we use small agents over other frameworks? Small agents is ideal when you need a lightweight and minimal solution. You want to experiment quickly without complex configurations. Your application logic is pretty straightforward. So this is important. This is more of like a learning tool. So if you're building something production for a business, you probably wouldn't go with small agents. That's probably why those other two frameworks are going to be a part of this course. All right, so code versus JSON actions. Unlike other frameworks where agents write actions in JSON, small agents focuses on tool calls in code, simplifying the execution process. This is because there's no need to parse the JSON in order to build code that calls the tools. The output can be executed directly. The following diagram illustrates this difference. Okay, so here's a diagram illustrating the difference. So, instruction: determine the most cost-effective country to purchase the smartphone model Kodak 1. The countries to consider are USA, Japan, Germany, and India. So now we've got APIs to use. The agent can use these APIs. So if we were to use JSON slash text slash JSON as action, then we would have to perform multiple actions, which cost tokens, which add latency. So not so good. So here's the thought process of the LLM agent. I should calculate the phone price in USD for each country, and then find the most cost-effective country. So so I need to look up the rates. I need to look up the price. I need to do all of this one by one by one by one because I don't have the ability to use code. So if you give your LLM agent the ability to use code, which you can do with the Code Act library, right? Uh, let me see here. So let me create a duplicate of that, and then go to my profile and look at the files. So I think, yeah, I think this you can use this code agent, and now the agent has the ability to use code. I think. Let's look at the docs here. So open that in a new tab. Code agent. Oh, I searched the wrong thing. I need to search the docs. Okay, so yeah, here we go. So this is a class for an agent that solves the given task using a single block of code. It plans all its actions and then executes all in one shot. So this is it. Transformers.code agent. So this is how you would call that in. From small agents, import code agent, and then once you have that code agent, you build the agent using the code agent. So now you have an agent that can use code. So now look at this: 1, 2, 3, 4. You've only got 4 actions, or you've only got 4 things. It doesn't have to keep doing everything. So I'm going to take a moment because I need to explain this concept to someone, um, and uh, and I'll be right back. All right, welcome back. So I'm going to read code versus JSON actions. Unlike other frameworks where agents write actions in JSON, small agents focuses on tool calls in code, simplifying the execution process. This is because there's no need to parse the JSON in order to build code that calls the tools. The output can be executed directly. The following diagram illustrates this difference. So a lot less actions required if you can use code to put the actions in, to put it in a for loop and do it all as one action, which is executing that code, rather than having to take multiple actions that cost more, add more latency and cost more tokens. To review the difference between code versus JSON actions, you can uh, revisit the actions section in Unit 1. All right, and I will pause, be right back. All right, I'm back. So let's see here. So yeah, to review the, you know what? Let's go back and just read that out loud because I think I do need the review here. So these are actions enabling the agent to engage with its environment. In this section, we explore the concrete steps an agent takes to interact with its environment. We'll cover how actions are represented using JSON or code, the importance of the stop and parse approach, and introduce different types of agents. Actions are the concrete steps an agent takes to interact with its environment. Whether it's browsing the web for information or controlling a physical device, each action is a deliberate operation executed by the agent. For example, an agent assisting with customer service might retrieve customer data, offer support articles, or transfer issues to a human representative. All right, so the types of agent actions. There are multiple types of agents that take actions differently. So there's a JSON agent. The action to take is specified in JSON format. There's the code agent. The agent writes a code block that is interpreted externally. And then a function calling agent. It's a subcategory of the JSON agent, which has been fine-tuned to generate a new message for each action. Actions themselves have many purposes. That's okay. We'll skip that. Um, yeah, so one crucial part of an agent is the ability to stop generating new tokens when an action is complete. And that is true for all formats of agent, JSON, code, or function calling. This prevents unintended output and ensures that the agent's response is clear and precise. The LLM only handles text and uses it to describe the action it wants to take and the parameters to supply the tool. All right, so now, yeah, so an alternative approach is using code agents. The idea is instead of outputting a simple JSON object, a code agent generates an executable block of code. So yeah, so let me pause. I'll be right back. All right, welcome back. So yeah, so that's the review. Finished with that. So moving on. Agent types in small agents. Agents and small agents operate as multi-step agents. Each multi-step agent performs one thought, one tool call, and execution. In addition to using code agent as the primary type of agent, small agents also supports tool calling agent, which writes tool calls in JSON. We will explore each agent type in more detail in the following sections. In small agents, tools are defined using at tool decorator wrapping in a Python function or the tool class. Model integration in small agents. Small agents supports flexible LLM integration, allowing you to use any callable model that meets certain criteria. The framework provides several predefined classes to simplify model connections. Transformers model implements a local transformers pipeline for seamless integration. HF API model, HF presumably stands for Hugging Face, supports serverless inference calls through Hugging Face's infrastructure or via a growing number of third-party inference providers. Light LLM model leverages Light LLM for lightweight model interactions. OpenAI server model connects to any service that offers an OpenAPI or an OpenAI API interface. Azure OpenAI Server Model supports integration with any Azure OpenAI deployment. This flexibility ensures that developers can choose the model and service most suitable for their specific use cases and allows for easy experimentation. Now that we understood why and when to use small agents, let's dive deeper into this powerful library. So resources, they have a blog post that is the introduction to small agents and code interactions. So let's take a look. So this was actually published. Really, this is cutting edge stuff. This was published about 2 or 3 months ago. Yes, this is cool. I'm just briefly looking through this. So it unlocks agentic abilities for language models, for any language model. You choose, you define the language model right here. Um, so we can see, yeah, so cool. So what are agents? An efficient system using AI. Um, an agent is a it, a gateway to the outside world. Yeah, this is a great article. I'm gonna share this. Yeah, multi-agent. This is great. This tells you when to use them and when to avoid them. I'll be right back. All right, I'm back. So let's take the quiz. So this is just the quick quiz. It's not to get a cert or anything. So it's an ungraded quiz. So I'm just gonna show it here. If I were doing like a graded quiz, I would pause the video, take the quiz, and then show the results. So I'm not showing the answers out in public. So let's test your understanding. Small agents with a quick quiz. I think these are also typically pretty easy. Yeah, let's do that. So with a quick quiz, remember, testing yourself helps reinforce learning and identify areas that may need review. This is an optional quiz and it's not graded. So question one, what is one of the primary advantages of choosing small agents over other frameworks? So which statement best captures the core strength of the small agents framework? Um, yeah, so I think it's this. It supports a code first approach with minimal abstractions, letting agents interact directly via Python function calls. Um, yeah, the other ones, this is kind of easy. So the first one's a not a obviously false answer. A benefit is not going to be that it has a steep learning curve. That would be a drawback. Um, the other one is an obvious wrong answer. It wouldn't be a benefit for the agent to have Python to have JSON-based actions rather than code-based actions because they couldn't do something like putting a call in a for loop if it had to do the call many times. So that's a disadvantage, not an advantage. Um, and then this would be a disadvantage as well, being locked into a single LLM provider and having to use specialized hardware. The great thing about this framework is it'll work with any model you bring forward to it. So all you need to do is some research to figure out what model works with the hardware you already have, and you're up and running just to develop. And then you need to do further research to determine what model accomplishes the goals you have. And if that means upgrading your hardware, then you need to do that. So, but you can get started right away with whatever model works best on the hardware you already have, and seamlessly swap out the model later. So, yep, I got that right. So, question two, in which scenario would you likely benefit most from using small agents? Which situation aligns well with what small agents does best? All right, so yeah, I think it's prototyping or experimenting quickly with agent logic, particularly when your application is relatively straightforward. Yeah, so it's not going to be for large scale enterprise systems. It's not going to be for if this one is kind of an obvious answer, you wouldn't want a framework that only supports cloud-based LLMs and forbids local inference. Uh, yeah, and then a scenario that requires uh, yeah. So this is just a quick. This is basically for learning. It's designed for simple and nimble agent creation without extensive setup overhead. So we'll be learning about two other frameworks later that can be used for advanced orchestration, multimodal perception, and enterprise scale features. All right, question three. Small Agents offers flexibility in model integration. Which statement best reflects its approach? Choose the most accurate description of how Small Agents interoperates with LLMs. It only provides a single built-in model. Okay, so how it best? So it's yeah. So obviously the answer is this. How does it interoperate with LLMs? It only provides a single model and does not allow customization. Nope, wrong answer. That would be very bad. Would hope that would not be the right answer. It requires you to implement your own model connector. Nope, it has a model connector. So HF API model, I think, is what it is. Um, so you can use it with any model. It only integrates with open source LLMs, but not commercial APIs. And that's the key thing that is wrong. If I hit submit, I got that correct. Small Agent supports flexible, modelable integration of various classes, including with a commercial solution. So you can use this to prototype out your business, what you're doing, and you're going to run it on a potato, right? Like you're going to have no juice, but it's like you can build your uh, horse and buggy system using a donkey because you can't afford like a super nice horse. And now people see how nice your carriage is, how nice the everything is, and now you can just seamlessly swap it out for a better horse. So like it's really a great thing for prototyping. So, question four, how does Small Agents handle the debate between code-based actions and JSON-based actions? Which statement correctly characterized Small Agents' philosophy about action formats? It focuses on, yeah, so it focuses on code-based interactions via code agent, but also supports JSON-based tools with a tool calling agent. Okay, so this one, first one would definitely not be right because it made a point that JSON-based actions are not as good, so it wouldn't force you to do that. This allows any external function calls. Um, nope, that's the opposite of what it does. Both of them allow you to uh, are basically the opposite of that. It requires users to manually convert every code snippet. No. So B is the right answer. Small Agents primarily recommends code-based actions, but includes a JSON-based alternative for users who prefer it or need it. All right, so question five, how does Small Agents integrate with the Hugging Face Hub for added benefits? Which statement accurately describes one of the core advantages of hub integration? So, yeah, I think so this last answer here permanently stores all of them, preventing updates or versioning. Nope, that would be terrible. Disables local inference entirely, forcing you to pay for some sort of API. No, that would be very bad. It automatically upgrades all public models to commercial license tiers. That sounds very bad as well. Um, So the correct answer, it allows you to push and share agents or tools, making them easily discoverable or reusable by other developers. Small Agent supports uploading agents and tools to the Hugging Face hub for others to reuse. Isn't that awesome? Like I love Hugging Face, and I like how they're so like I like their branding too. Like their branding is a hugging face, somebody welcoming you into a community. And it's all about rapid prototyping. It's all about collaboration amongst other developers. This is definitely the place to be. All right, so congratulations on completing this quiz. If you missed any questions, consider reviewing the Why Use Small Agents section for a deeper understanding. If you did well, you're ready to explore more advanced topics in small agents, building agents that use code. All right, so we're still in Unit 2.1. So let me check the clock quick. If it's at an hour mark, I do have a hack. I can take a somewhat extended break and go on for another hour. Let me take a very short break now and then continue on. All right, I'm back. So I'm going to do another 15 minutes. Should be pretty doable, and then take an extended break and come back. All right, so this is building agents that use code. Code agents are the default agent type in small agents. They generate Python tool calls to perform actions, achieving action representations that are efficient, expressive, and accurate. Their streamlined approach reduces the number of required actions, simplifies complex operations, and enables reuse of existing code functions. Small Agents provides a lightweight framework for building code agents implemented in approximately 1,000 lines of code. So so this graphic came from the paper they wrote on executable code actions elicit better LLM agents. So yeah, it's important. So yeah, the paper came from there. So yeah, you really want to give your agent the ability to use code. It's just much better than otherwise, according to them. Um, and in fact, they built a tool to create agents that does it by default. All right, hold on a second. All right, I'm back. Let's try to get to that hour mark here and then take a more of an extended break. All right, so they wrote a paper on why executable code actions are better than an agent directly using an API. It's better to have it use it through writing code than just using it directly. Okay, so if you want more information about why code agents are effective, you can check out this guide from the documentation. Yep. So the Hugging Face is very clear about this. Code agents, code agents, code agents. It'd be interesting to hear what other entities have to say. All right, so why code agents? In a multi-step agent process, the LLM writes and executes actions, typically involving external tool calls. Traditional approaches use a JSON format to specify tool names and arguments as strings, which the system must parse to determine which tool to execute. However, research shows that tool calling LLMs work more effectively with code directly. This is a core principle of small agents, as shown in the diagram above. From executable code actions elicit better LLM agents from the paper. So we should see that same graphic in the paper. Let's take a look at that. Yeah, so it's right there on the second page of the paper. All right, so writing actions in code rather than JSON offers several key advantages. Composability. Easily combine and reuse actions. Object management. Work directly with complex structures like images. Generality. Express any computationally possible task. Natural for LLMs. High quality code is already present in LLM training data. How does a code agent work? How codeagent.run works. So, one, preparation. Put the task and images into a task step and add it to the logs. There we go. So code agent logs, very detailed, token counts durations, system prompt step, task step, action step. Number two, while final answer tool has not been called, while it has not been called, agent.write inner memory from logs, parses logs to make a list of LLM agnostic chat messages. So parsing and generation. These chat messages are sent to the model, LLM/VLM. The model returns a string answer, including a code blob that is extracted. And then execution, 2.3. So we got the model, handles all the LLM calling and post-processing logic. Tools, list of tool objects. So the code blob is executed. Any tool calls in it call the specific tools as functions, then continues running the code. So 2.4, all execution logs, including possible errors, are put into an action step that gets appended to the logs. A callback can take a screenshot and add it to the step under observation images. So action step, there we go. So number 3, when final answer tool has been called, run, there we go, returns its argument. So the diagram above illustrates how codeagent.run operates following the React framework mentioned in Unit 1. The main abstraction for agents in small agents is a multi-step agent, which serves as the core building block. Code agent is a special kind of multi-step agent, as we will see in an example below. A code agent performs actions through a cycle of steps, with existing variables and knowledge being incorporated into the agent's context, which is kept in an execution log. Number 1, the system prompt is stored in a system prompt step, and the user query is logged in a task step. Then the following while loop is executed. 2.1 method agent.write memory to messages writes the agent's logs into a list of LLM readable chat messages. 2.2 these messages are sent to a model, which generates a completion. You can use any model you would like. 2.3 the completion is parsed to extract the action, which in our case should be a code snippet since we're working with a code agent. 2.4 the action is executed. 2.5 the results are logged into memory in an action step. At the end of each step, if the agent includes any function calls in agent.step callback, they are executed. All right, and I'll only now do a sound check. All right, looks good. Let's see some examples. You can follow the code in this notebook that you can run using Google Colab. So looks like there's a notebook associated with this 2.1, so I'll definitely give a try to go through that. Oh, one thing I forgot to say that really sucks about Google Colab is that there's a login timer, and you automatically get logged out after a certain amount of time. So I don't know if you can adjust that timer. If you can, I recommend disabling that timer or setting it to the longest possible. I'm sure you can, like, I can't imagine that there wouldn't be a way to disable the timer, because what happens is you start training a model, and then you get logged off after 3 hours, but the model needed 6 hours to train. So, what happens then? Does the model just stop training? Does it keep going even though you're logged off? I don't know the answer to that. So the easiest answer is to just don't log off. Um, but that's something. You know what? Let's go ahead and have a conversation with the AI. I know brand spanking new, from what I understand. Ah, not yet. I thought there was going to be a new feature released today at 12 p.m. Pacific time, but it's an hour past that, so yeah, I don't see anything new released. But let's have a conversation with the AI about that. Hi, are you familiar with Google Colab?
Yes, absolutely. Google Colab is a free cloud-based platform that allows you to write and execute Python code in a browser. It's especially popular for data science, machine learning, and deep learning tasks. Have you used it before?
Yeah, I'm using it now. So is there an auto timeout feature where when you're logged in, you automatically get logged out after a certain amount of time?
Yes, Google Colab does have an auto timeout feature. If you're inactive for about 90 minutes, the notebook will disconnect to free up resources. If you run a cell, it resets the timer. However, sessions can last up to 12 hours in total before they automatically terminate, even if active.
Okay, and there's no way to like toggle that. You can't like increase the timeout value or anything.
Unfortunately, there's no built-in way to increase the timeout value in Google Colab. The limits are set by the platform to manage resources. However, you can keep your session active by periodically interacting with it or using a small script to prevent it from disconnecting. Just be aware that this still won't extend the maximum session limit.
Okay, and you said the maximum session limit is 12 hours?
Yes, that's correct. Each session can last up to 12 hours, after which it will automatically terminate even if you're actively using it.
Okay, and to get to that 12 hours, you have to find a way to keep your session active every 90 minutes.
Exactly. You can do this by periodically running a cell or using a small JavaScript snippet that simulates activity. But remember, even with this, the session will still end at the 12-hour mark. So it's a good idea to save your work frequently.
Okay, so you can get 12 hours of time on Google Colab if you like create a JavaScript thing for your browser that like automatically like refreshes the browser every like 89 minutes, right?
Exactly. Something like that would help keep your session active. Just keep in mind that this approach might not always be reliable, and it's important to save your work frequently. If the session does time out or terminate, you'll be able to reconnect and pick up where you left off.
Well, I mean that's really like kind of disappointing to hear, right? Because basically that sets a limit. It's like, yeah, you can buy GPU and you can like make something like training an AI model happen faster, but you still have a maximum time you can train. You can only train it for 12 hours. So depending on what you're doing, even if you buy the most expensive GPU they have and you set up that script to refresh the page so you can leave your training running for 12 hours, you might not be, you're going to be limited in what you can do because sometimes it takes days, weeks, or months to train a model.
It can definitely be limiting, especially for longer training tasks. For more extensive projects, you might consider using a dedicated cloud service or setting up your own machine with more flexible uptime. It's all about finding the right balance for your needs and resources.
Well, that's disappointing. Do professionals like not use Google Colab then? Because like I feel like that'd be super limiting.
Professionals do use Google Colab, but typically for prototyping, smaller tasks, or educational purposes. For more intensive and longer term projects, they often turn to other cloud platforms like AWS, Google Cloud, or Azure, where they have more control over resources and uptime. Colab is great for many things, but it does have its limitations for heavy duty professional work.
Oh, I see. So Collab is kind of more just for education and prototyping and stuff, but for like actual production thing, you would use something other than Collab.
Exactly. Collab is fantastic for learning, experimenting, and prototyping. But for production level projects or extensive workloads, professionals often opt for more robust solutions that offer greater control and scalability.
What if you get what if you pay for the like enterprise version? Do you still have to deal with that timeout issue?
With Colab Pro and Colab Pro Plus, you get access to longer runtimes and more powerful GPUs. However, there are still some limits, and sessions can time out if left inactive for extended periods. The exact details can vary, but these paid plans do offer more flexibility compared to the free version. For mission-critical, long-duration training, dedicated cloud platforms still provide the most reliability.
Okay, so it looks like you can pay and you can get 24-hour execution. So it looks like you can okay, so it looks like oh, and it looks like you can also completely okay, so it looks like Google Colab does have like, acceptable professional level services that it offers. You can pay for code execution to go up to 24 hours, and you can actually fully relax any runtime limits and idle timeouts by purchasing a dedicated VPN or a dedicated, not VPN, a dedicated virtual machine.
Yes, with Google Colab Pro and Pro Plus, you get more powerful GPUs, longer runtimes, and enhanced productivity features. For even more extended runtimes and resources, purchasing dedicated virtual machines or using cloud platforms can provide even greater flexibility and control. So yes, there are professional level options within Colab, but for some needs, a more robust setup might still be preferable.
All right, I guess that's fair. That makes sense. I was just worried that like you'd get used to using Google Colab, and then like when you actually want to do something serious, you have to move to another platform.
That's a valid concern. The good thing is that the skills and workflows you develop with Colab are quite transferable. So if you ever need to transition to another platform, it should be relatively seamless. Plus, having exposure to multiple tools can only broaden your skill set and make you more adaptable.
Yeah, and on top of that, Google Colab does have like enterprise offerings.
Exactly. Google Colab's enterprise offerings can provide more robust features and support for professional use cases. So you have options to scale up if needed, making it a flexible tool whether you're just starting out or working on more complex projects.
All right, so that was pretty helpful. So okay, so moving on. So so Alfred is planning a party at the Wayne family mansion and needs your help to ensure everything goes smoothly. To assist him, we'll apply what we've learned about how a multi-step code agent operates. Alfred, I need you to plan the party. Certainly, sir. If you haven't installed small agents yet, you can do so by running the following command. So let's do that. I'm going to pull up VS Code. Perfect. Then I'm gonna type it. So you have Docker installed. Do you want the recommended Docker? Sure, yeah, let's install it. Okay, now let's do, we're gonna type in bash and then cat etc os release. So this is my Debian instance. So let's type in wasl wsl dash dash list. Okay, so we've got a distribution for Debian. Let's set one up for Ubuntu on my other disk. How to set up a Ubuntu Wasl uh, VM on my D drive. All right, and I'll pause it and be right back. All right, I'm back. So it is at the hour mark, so I would like to take an extended break. I think that'll help. But let's go through this. Okay, so we have to import it. Um, yeah, we have to install it on the C drive and then import it over to the other drive, which I can't deal with that right now. All right. Well, you know what? I think I'm gonna end the video here. I'll restart my computer. I haven't restarted my computer in quite a while, and that'll make things like this easier to do. So I'm gonna end this, restart my computer, and I'll see you in the next video.